Okay, so in this video, we will look at a surprisingly elegant relationship between the price elasticity of demand and the marginal revenue function. So we will use, as always, P equals f of x for the demand function, recall that E stands for the price elasticity of demand, and it is calculated using the ratio of P over x over the derivative of the demand function, dP over dx. And as we proved, the price elasticity of demand is always negative, as P and x are positive, and dP over dx is negative, since we have a negative relationship between the price of a unit and the quantity demanded by consumers. We can also look at the revenue function. So R is the revenue function. It's a very simple function, right? To calculate your revenue, it is simply the number of units purchased by consumers times the price per unit. So if each unit is sold at a price P and X units are sold, well, then your revenue is X times P. So very simple relationship between the revenue function, number of units purchased by consumers, and the unit price of a given product. And if you recall, the marginal revenue is simply the derivative of R, the revenue function, with respect to X. As P, the demand function, is a function of X, what we have here is simply X times f of X. So R can be viewed as a function of X. So we can differentiate it with respect to X, and that is what we call the marginal revenue. Now, let's differentiate R with respect to X using the relationship that R equals XP. So dR over dx equals, well, the derivative with respect to X of, and now we'll simply replace R by XP. What's critical here is that we differentiate a product of two functions, X and P is another function of X. So we have to use here the product rule. So we have the derivative of the first function, dx over dx, times the second function, P, plus now the first function, X, times the derivative of the second function, dp over dx, the derivative of the demand function. Well, dx over dx is quite simply 1, so this becomes quite simply P plus X times dP over dx. Let me factor P out of this expression. If I do so, then I'm left here with a 1 plus, well, if I factor P from here, to cancel that off, I have to divide by P. So this will be an X over P times dP over dx. If you're not sure, just multiply through. So P times 1 is P. P times X over P, the P's cancel, and you're left with X times dP over dx. And what's interesting now is what happens if I, instead of multiplying dP over dx by X over P, I divide dP over dx by the reciprocal, therefore P over X. As we've used many times before, if you divide by a fraction, it's the same as multiplying the numerator by the reciprocal, the inverse of the fraction. So this is multiplying dp over dx by the inverse, which is x over p. So this works out. The question, of course, is why did I do this? Well, here's why it's interesting. dp over dx over p over x. So you see, this is nothing but the inverse, the reciprocal, of the price elasticity of demand. P over x over dp over dx, dp over dx over p over x. So this is nothing but the reciprocal of e, therefore 1 over e. And with this relationship between the marginal revenue function and the price elasticity, we can now reach a rather nice conclusion. So, let's recall the three possible values or range of values that the price elasticity can obtain, remembering that E is always strictly negative. So, let's go with the first range when E is strictly between -1 and 0. Well, this is if and only if the demand is inelastic Recall that this is equivalent to, in absolute value, E being strictly less than 1. And now, let's look at an equivalent form of this statement, E being between -1 and 0, if we look at the marginal revenue function. Now one thing is clear, P is the price of a unit. So P is always positive. So we have a product between the positive number and the quantity 1 plus 1 over E. So this whole expression, the marginal revenue function, will only be positive if this term is positive, and will only be negative if this term is negative. But now think about it. If E is between -1 and 0, then 1 over E is, well, of course, negative, as E is always negative. But if E is less than 1 in size, then 1 over E will be bigger than 1 in size. So what you have here is a number that is negative and bigger than 1. So that plus 1, of course, is negative. So you see, the demand is inelastic if and only if the marginal revenue function is negative. So when the marginal revenue function is negative, or when the revenue function is decreasing, as the marginal revenue function is nothing but the slope, the derivative of the revenue function, then the demand is inelastic. Well, what if we now look at elastic demand, when E is strictly less than -1, or equivalently, in absolute value, E is bigger than 1. This is the statement that the demand is now elastic. And let's look now at an equivalent formulation using the marginal revenue function. If an absolute value is bigger than 1, that means that 1 over E will be less than 1 in absolute value. So what you have here is a number that is less than 1 in absolute value and negative. Well, if we add 1 to that, it becomes positive, and so the marginal revenue function must be positive. So, the demand can only be elastic if the marginal revenue function is positive, or equivalently, if the revenue function is increasing. And finally, the last case is a unitary demand, and here there's only one possible value, E equals -1. So if and only if the demand is unitary if and only if, well, again, let's look at the marginal revenue. And this one is the simplest one. If E is negative 1, 1 over E is negative 1, plus 1 is 0. And so the marginal revenue function must be equal to 0. And that is the relationship that exists between the price elasticity of demand and the marginal revenue function. So there's two ways to look at this. If we look at the marginal revenue function, then the demand is inelastic if the marginal revenue is negative, elastic if the marginal revenue is positive, and unitary if the marginal revenue is equal to 0. If you think about the revenue function, then the demand is inelastic if the revenue function is decreasing, as it has a negative derivative. The demand is elastic if the revenue function is increasing, as it has a positive derivative. And the demand is unitary if the revenue function is flat at this point, as the derivative is equal to 0. And that's it.